Beneath every skyscraper, bridge, or heavy load structure lies a deep and critical foundation. But in terrains where shallow foundations won't do, engineers turn to a powerful method: board piles. Giant vertical columns drilled deep into the earth to hold up thousands of tons. In this episode, we're going behind the scenes of board pile drilling, exploring how these gigantic shafts are formed, stabilized, reinforced, and filled. From massive auger rigs to creamy concrete placement, we'll uncover every step that transforms raw ground into one of the most reliable, deep foundation systems in modern construction. Every board pile starts with precision planning. Engineers begin with geotechnical surveys to determine soil profiles. Identifying layers like clay, sand, silt, gravel, and rock. Once the load-bearing depth is determined, site crews mark out pile locations using GPS and laser-guided total stations. Each pile might be spaced several meters apart, depending on the structural design. Before drilling, the surface is leveled and cleared. Temporary guide walls or pile casing collars are installed at each bore point. These guide rings, usually made of steel or concrete, keep the drilling shaft aligned and prevent soil collapse at the surface level. Once the setup is complete, it's time for the heavy machinery to move in. The core of the operation is the rotary drilling rig, a massive machine that rotates a large auger or drilling bucket to excavate the earth. These rigs can weigh over 80 tons and tower several stories high. The drill is powered by hydraulic motors capable of generating immense torque. The auger can drill diameters ranging from 600 millimeters up to 2,000 millimeters, and depths reaching 60 meters or more. There are two main types of tools: continuous flight auger, CFA, a spiral-shaped drill that pulls up soil as it drills. Kelly bar drills, a telescopic drill shaft with replaceable drilling buckets used for deeper, more complex formations. As the drill descends, it brings soil and rock fragments to the surface. Spoils are removed by conveyors or excavators and transported off-site or reused for fill, depending on contamination levels. In water-bearing soils or loose sand, support fluids like bentonite or polymer slurries are added to stabilize the borehole walls during drilling. Each drill cycle may take 15 to 45 minutes, depending on depth and material hardness. When the desired depth is reached, drilling stops, and the shaft is cleaned for the next phase. Once drilling is complete, the borehole must be cleaned thoroughly to remove sediments, loose materials, and ensure a clean base. A clean-out bucket is lowered to the bottom of the hole. This bucket scoops residual debris and ensures that the shaft bottom is flat and free from silt. In water-filled shafts or slurry-stabilized bores, a tramy line or airlift system may be used to suck out fine sediment. The heart of the board pile's strength comes from its reinforcement cage, a cylindrical assembly of rebar that resists tension and shear forces. The cage is prefabricated nearby using steel rebars, vertical main bars, longitudinal reinforcement, circular or helical stirrups, lateral support, centralizers to ensure 75mm concrete cover on all sides. Cages can be over 20 meters long and may weigh several tons. Large cranes or service rigs are used to lower the cage into the borehole carefully. Sometimes the cage is spliced in sections using couplers or welding, especially for ultra-deep piles. Critical that the cage remains centered throughout its length, which is why centralizers are fixed at intervals. Misaligned cages can lead to exposure, where steel is too close to soil or not embedded properly in concrete. Before concreting, conduits or sleeves may be inserted for integrity testing, like cross-hole sonic logging, later. Concrete must be poured in a continuous and controlled manner to prevent segregation, air pockets, or cold joints. This is done using the Rotary method. A vertical pipe, typically 200 to 300 millimeters in diameter, is inserted into the borehole, reaching near the bottom. The pipe is sealed at the base to prevent water or slurry from mixing with concrete. Concrete is then pumped into the pipe, and as it flows, it displaces slurry or water upwards. Key parameters: concrete must have high slump fluidity, typically 180 to 220 millimeters. Anti-washout admixtures are added in water-bearing soils. Concrete volume is monitored carefully to ensure full fill. As concrete rises, the Rotary pipe is slowly withdrawn, always keeping its outlet embedded in fresh concrete to avoid contamination. Displaced slurry is collected in tanks or pits and recycled or treated according to environmental standards. Once concrete reaches the surface and is visibly sound, the Rotary is withdrawn. Any leftover spoil or contaminated concrete at the top is removed after initial setting. After placement, board piles require proper curing and testing. Curing occurs below ground, but in some cases, the pile head is exposed and cured with wet coverings or curing compounds. Within a few days, pile integrity is tested using methods like low-strain integrity test, PI, checks for cracks or necking via vibration response. Cross-hole sonic logging, CSL, uses inserted tubes to verify internal soundness. Pile load tests measures actual load capacity using hydraulic jacks or reaction piles. If any defects like honeycombing or inclusions are detected, remedial measures may include jet grouting, segment demolition, or replacement piles. Once certified, the pile head is trimmed to cut-off level using jackhammers or hydrodemolition, ready for pile construction. From a simple steel cage in a hole in the ground to a deep concrete column supporting thousands of tons above, it's a process that combines engineering precision with raw power. Board piles are silent giants beneath our feet. Invisible, but indispensable. Whether you're walking across a suspension bridge or working inside a high-rise, chances are you're standing on the results of this remarkable process. Thanks for joining us in this episode of How It's Made, Deep Foundations. Don't forget to subscribe for more in-depth looks into the hidden marvels of the industrial world.